Cool. Thank you very much. And thank you very much to everyone for making the effort. I know it's extremely early, so thank you for coming along. Really appreciate it. And I'm going to dive straight in. So don't get too scared, but there's a couple of lines of code on the next two slides. Nothing to be too scared of this time in the morning. Okay, so in this unnamed programming language, I've got a couple of lines of code, and this console.log is just printing to the screen. And those little sort of comments, the little sort of two slashes to the right hand side, are telling you what the output is of those lines of code. So the first line there does 3 minus 1, and that gives you 2, which even this early in the morning, I can agree with. That's all good. The second line down, that says 3 plus 1 is 4. Again, I think I can agree with that. One more line down again, we've got the character 3 minus 1, rather than the integer. And that also gives you 2. Okay, I can just about believe that that's sensible. But then my question to you is, what does the fourth line output, which is the character 3 plus 1? And there's 4 options at the bottom. I'm not going to get you to put your hands up or anything, just sort of have a think yourself and convince yourself what you think the most obvious option is. So is it A? Is it 2? Is it 3? Is it 4? Or is it 31? Give you like 10 seconds to just mull that over and think what you think the most obvious thing might be. Okay, I'll reveal the answer. I was kind of horrified to learn this, but the answer in this unnamed programming language is 31, which I found quite surprising, personally. In 3 slides' time, I'll reveal what the programming language is. But let me show you another example. This is another example where I'm letting a variable x equal the sum of these 2 integer arrays. So we've got one array, which is 1, 2, 3, and then added with 4, 5, 6. And then I'm just going to add them together and log the output. So the options are essentially what I've written at the top without the square brackets and the plus. That's what we're going to output without the comma between the 3 and the 4. There's a version with the comma between the 3 and the 4. There's a version where the elements have been added element-wise. So 1 plus 4 is 5, 2 plus 5 is 7, and 3 plus 6 is 9. And then there's a fourth option, which is actually just concatenating the arrays and just making them 6 long with the numbers 1 through 6. I'll give you a few seconds to think about what you think the answer to this one might be. Okay, and again, I would say this is the least obvious option to me. It's actually option A, which again is just the most unsensible of the 4 options, I think. One final example for you. This is a bit of an infamous one. I'm going to log the output of the string B added to the string A, added to the string A, add the string A. And the output can be banana, banane. I'm not even going to say that the final 2 options. And in actual fact, I'm not going to trick you this early in the morning. It is what you'd expect from the output that it's actually. But again, from the operations at the top, I don't think that's the most obvious answer. It wasn't obvious to me anyway. So you might have guessed it already. This programming language here was JavaScript. And according to the 2024 Stack Overflow survey, JavaScript was the most popular programming language. I think the question they asked was, which programming, scripting, or markup languages have you done extensive development work in the past year, and which do you want to work on in the next year? And JavaScript came top in that list. So it's obviously a very popular language, although it has some weird quirks. And if you go to this URL here, which is bit.ly/WTF JavaScript, which is most people's reaction to seeing the previous slides, and there's a few more examples of sort of interesting quirks of JavaScript, which are kind of mildly entertaining. But I think one of the reasons that JavaScript is so popular is just because the web is such an instantly cross-platform place to deploy your applications. You know, it's so easy to fire up a web browser and just go to a URL and access your applications. I think some of the examples I've shown here explain why some people might want to avoid JavaScript, or why people do avoid JavaScript. And there's a couple of solutions to that, one of which being TypeScript. That's obviously JavaScript with types, and that solves, I think, almost all of the problems that on the previous slides. You know, if they had types, it would be very clear what the output should be. But the one I've got in bold here is one of the main 2 topics of today, which is WebAssembly, which is another way that you can run client-side code in a web browser. So I'm going to give you a very, very brief intro into WebAssembly. So WebAssembly, I didn't actually know about WebAssembly until quite recently, actually. I was surprised that it existed. But just like JavaScript, it runs in web browsers, and it's very kind of low level in comparison to JavaScript. basically you have your programming language and it compiles to sort of intermediate bytecode, and then that runs in your browser. But because it's a lower level or way of compiling your code to, it can use your computer's resources much more efficiently. On the WebAssembly website, it actually sort of states we are not a replacement of JavaScript. The idea is that WebAssembly sort of complements what's already achievable with JavaScript, except you might want to do more intensive operations with WebAssembly, for example. And there's a few sort of APIs that you can link into with WebAssembly. For example, talking to JavaScript, asking JavaScript to do certain things. WebAssembly is maintained by the World Wide Web Consortium, which is that W3C logo at the top. And as you can see, there's lots of recognizable brands that have had some influence into how WebAssembly has been created. Most notably, there's the makers of Firefox, Edge, Safari, and Chrome that have had some input into how this works, which is obviously great because all the main web browsers need to support WebAssembly. So with that kind of little motivation, I'm going to introduce myself properly. So hi everyone, I'm Adam. Thanks again for coming this morning. I know it's mega early. I struggled to get out of bed this morning. Okay, and today's talk is going to be split into 4 uneven parts. I'm going to give you a little bit about my background, just because it might be interesting to see where I'm coming at with all of this. And then I'm going to give you an introduction to Blazor and what Blazor is, a bit more information on what WebAssembly is and how it works, and then it's going to be some interactive demos towards the end, showing Blazor in action. The main 2 aims of today are really to get you excited about Blazor and get you excited about WebAssembly. With that said, I will note now that I am absolutely not an expert, and this is very sort of high level. If you ask me a technical question, I might not know the answer, so I'm sorry. So very quickly, so my background, I started programming, my dad showed me PHP all the way back in maybe like 2007-ish. That's kind of what started my program journey. So kind of from the start, I've kind of been into kind of web apps, really, although the interactivity came much later. And kind of before I came to university in Nottingham, I was sort of mucking around with different websites, obviously using HTML and CSS, but also PHP to generate some dynamic content. In 2016, I moved from Newcastle, North Shields, in the northeast, down to Nottingham, and I did a maths degree where I focused on scientific computation, which is a way of essentially doing maths in programming language, essentially how you convert maths equations and solving them to something like code to do that for you. So I did a lot of programming in MATLAB and C++. And in my personal opinion, the only language worse than JavaScript is MATLAB. That's a personal opinion. I then moved on to do my PhD, where I wrote some software that modeled blood flow in the human placenta. We looked at nutrient transport between mother and baby, which was quite interesting. And I did a lot of programming at the time in Fortran and Python, and also got the awesome opportunity to do some teaching in Python at the same time, which was really great. And as of last year, I've been working at a place called Savoy Systems, where we make ticketing software for cinemas and theatres. We do a lot of stuff in both Delphi and C#, and of course, Blazor. So I'm going to give you a bit of a background on Blazor. So I'm going to start with a brief history of interactive web apps. So if you remember all the way back to the 1990s, I must admit I was only just alive in the 1990s, but there was the era called Web 1.0, where websites were mostly static. You just generated, for example, like a single HTML page, and that's how most of the internet was developed. Later in the 90s, languages such as PHP and ASP came along that allowed you to sort of put some dynamic content into those web pages and serve them. And also in 1995, JavaScript was released. As it happens, although I poo-pooed JavaScript a few slides ago, I would like to point out that from the inception of JavaScript, the idea has been that JavaScript will be a language for the masses. It was the idea from the start was that it should appeal to non-technical people as well as technical people, which I think is why we have some of those syntactical quirks that we saw earlier. And obviously, it's great to have some client-side computation on a web browser. I think that's obviously a really important thing to have. JavaScript, when it was first released, was actually called LiveScript, but at the time, Java was becoming a lot more popular, and I think the article I read sort of hinted the fact that they probably put it as a bit of a marketing ploy to put JavaScript instead of LiveScript, although obviously JavaScript has nothing to do with Java. We then move forward to the 2000s. Things like Ajax came along, which is asynchronous JavaScript calls, where you could make calls to the browser to update the page and then talk to a server. And some other things there as well. I remember in the 2000s playing lots of Flash games when I should have been at school, or concentrating in school, I should say. In the 2010, we moved on to single page apps with things like AngularJS. So these are pages that load the resources once on the initial load, and then can do some updates to the DOM in the web page to update the page's content. A little bit further on in the 2010s, we came across some of our more modern frameworks that deal with things like that, like React. And then in 2017, WebAssembly was first launched. And from the outset, you saw that Mozilla, Google, Apple, and Microsoft all had input from the beginning. And from the outset, all four of these main browsers supported WebAssembly. And obviously, it's kind of an alternative to JavaScript, and it's arguably the only sort of real main way, apart from installing like plugins, of doing some sort of client-side execution. In 2018, Microsoft adopted Blazor as an experimental project. The word Blazor actually comes from a combination of browser and Razor. So Razor is a combination of C# and HTML code to allow you to generate some dynamic web pages. And then Blazor kind of combines the interactivity with the browser and maintains that link between the server and the browser. And then 2 years later in 2020, Blazor was officially supported by Microsoft and supports WebAssembly, which I'll talk about shortly. So to be more specific about what Blazor is a web framework that allows you to get something off the ground running really quickly with lots of really nice sort of features. It's a single page app, an SPA. So roughly speaking, it loads once and then it does manipulations to the document to update the page's content. And it uses Razor, as I've mentioned. There are a couple of different hosting models that I'll quickly explain. So the main three are Blazor Web App, the WebAssembly, and the hybrid version. Inside the Blazor Web App, there's then 4 kind of subcategories of hosting, which are kind of interesting. So there's one way where you can basically serve static Razor content. That's one way of hosting your Blazor application. There's another version where you have something on the client side that's sort of JavaScript that's managing sort of requests from the server and then talking to the server. You've got interactivity on your web page. There's a version that combines that with WebAssembly, where you're allowed to sort of hook into to WebAssembly on the client's browser. And there's also an interactive auto version. Where that comes into play is essentially an interactive server, because you've just got the document loaded. That's kind of quite fast load. Whereas when you want to load WebAssembly, you need to load all of the web sort of the assemblies that you need and all the bytecode to be able to run and execute this yourself. So in general, depending on your application, the WebAssembly version can be a little bit slower to load because you've got more resources to download and then execute. So the auto version basically does a server load the first time. Then once all the binaries are downloaded, you can then execute that on your browser going forwards. The final 2 options here, WebAssembly, you can actually write a totally client-based app that actually has, your server would just serve the files, and there actually be you don't necessarily have to have any communication with the server, and it'll run entirely locally. It can be combined with things like progressive web apps, if you wanted to do it that way. And there's a final option, which is a hybrid option. If you've heard of something called .NET MAUI, MAUI somehow stands for Multi-Platform App UI. I don't know where the P got lost in platform, but that's what it stands for. So you can deploy to several different platforms at the same time. For example, if you wanted to develop a web app and an Android app and an iOS app, you might use MAUI, which combines the client and server side of Blazor into one. I'm going to very briefly give you some details about how it works. Obviously, .NET being a very object-oriented language, all of the reusable components that you might have seen in other web frameworks are essentially .NET classes, which allows you to hook into different methods and use different properties that are automatically available to you in .NET. This allows you to do things like binding of parameters, where essentially you can have a variable in your class and bind this to certain UI elements on your page, which I'll demonstrate shortly. It also allows you to interop with JavaScript. So basically, you can actually do some really cool stuff where your C# code can call a JavaScript function And JavaScript can also make calls back to C# functions as well, provided you've got it set up in the right way. And it being a Microsoft product, all of the communication between the server and the client is maintained by something called SignalR, which is kind of like an abstract communication layer. Most of the time, all being well, it's essentially using WebSockets behind the scenes, but it might defer itself to less intensive ways of communicating, I guess. If it needs to, do like things like long polling, where it will only sort of periodically check in with the server rather than maintaining a constant connection. I'm just going to very briefly explain these diagrams here. So in the server way of hosting, essentially you've got all of your .NET code and your APIs, server DOM, all on the server, and then the SignalR connection is passing this down to the client browser. There's a bit of JavaScript on the client's end that's sort of rendering that, and then also sending back to the server any sort of like clicks or any sort of event handlers you've got on the client side. On the other side, on the WebAssembly version, which is on the bottom, instead, you've only really got you're serving the WebAssembly files to begin with from your server, but then you might only have your API endpoints on your server. And everything else runs entirely in your browser, including the .NET runtime, which is really impressive, I think. So I've put a few links to a few different resources that I use to kind of, develop this talk, which I think are quite interesting. And the Modern.NET Show has a few interesting podcast episodes that talks about Blazor. And there's lots of stuff on the Microsoft website as well. And obviously, Google very much came to my rescue at times of need. I'm going to briefly tell you a little bit more about WebAssembly, and then we're going to move on to some interactive demos. So I mentioned before that WebAssembly is essentially it's computing stuff on the client side. And interestingly, it's a little bit more locked down than JavaScript. So the most notable kind of thing that's different with WebAssembly as opposed to JavaScript is WebAssembly can't interact with the DOM. You can't manipulate the DOM in the same way you can in JavaScript, which I thought was kind of surprising. But something you can do is you can use some interop things in WebAssembly to talk to JavaScript to ask it to do those things for you. So you can imagine in a sort of production environment, you might want to have your JavaScript doing your non-intensive tasks that you would do ordinarily. And anything intensive, you might delegate over to WebAssembly. So in bold here, I've got a few examples of a few apps that have been developed in WebAssembly recently. So Figma being the first one, so that's for designers and developers to create UIs. It's obviously quite an intensive process, I guess, making those. So I guess that's maybe why they've chosen WebAssembly to write their web app. eBay, apparently, there was a little article I read where they said they had a JavaScript implementation of basically having a real-time barcode scanner that had a camera built in, but it was far too slow in JavaScript on most devices. So they wrote a WebAssembly app, and apparently performance improved a lot more by doing that with the real-time camera scanning. And there's also something called WordPress Playground. If you're familiar with PHP like I am, you'll know that something called WordPress. In actual fact, I think that something like 70% of all websites are actually run on WordPress. But WordPress Playground is actually, you visit a web page and it downloads all of the resources you need to run WordPress locally, and it runs entirely in your browser. So it comes down with an SQL server, a PHP server, and runs entirely locally, which is kind of cool. So if you want to mess around with WordPress without any of the install headaches, you can just go to that website and it'll just run entirely in your browser. It's really cool. And Photoshop are apparently in beta testing of a version of their intensive image editing software, which is cool. And apparently BBC iPlayer are also soon to release a WebAssembly video player. So if you're interested in WebAssembly, this is the list of languages on the WebAssembly website that compile to WebAssembly already. So if you program in any of these languages, you can already do a bit of clicking and button pushing to compile to WebAssembly. So if you're interested in giving that a go, you can maybe visit the link at the bottom and give that a go. Okay, so on to the more interesting part of the talk, where I've got a few interactive demos. It wouldn't be an interactive web app talk without some interactive web demos. So if you want to get phones or laptops or whatever devices you have out, and you can scan that QR code or go to the link at the bottom. A few seconds to get that loaded up. Okay, I'll move on to the next slide, but the link will be in the top right if you want to get hold of it. So the first 3 of the 7 demos on that website are they're really lazily just the default apps from if you create a new Blazor project in Visual Studio. You might recognize them if you've done some work on this already. So most notably, if you click on any of the 3 and you click in the side menu and click on counter, basically the only interactive thing really is that click me will increment a counter. In actual fact, what I'm going to do is, since I'm sharing my screen, I think I'll flip over to this in a web browser. So if we were to go on to, say, the server one, which is the first demo, on counter, there's this little interactive bit of button clicking. I've realized this isn't over here. Okay. Sorry. Where's my... There we are. This is interactive button clicking like this. So nothing really special about this. Click on the button to go back. Okay, but something that's interesting is we can see how these would demonstrate, how these would behave if I was to turn the server off. So I talked about WebAssembly running entirely locally. So if you fire up, if you open maybe in a new tab, if you open all 3 of these demos, and then maybe if you navigate over to, I don't know, the counter page on each of the 3 of them, we can see how each of them might behave if I was to turn off the server. So I'll give you a few seconds to fire up the counter page on all 3 of those examples. And then I'm going to turn the servers off and we're going to see how the interactivity is affected. Okay, I'm going to turn off those 3 servers now. What you'll see is on the Blazor server version, it's attempting to reconnect to the server because the server's gone down. The WebAssembly version is entirely unaffected. Actually, I'm a little bit surprised that the auto one's gone off, but I'm not hugely surprised. But certainly on the WebAssembly version, as long as you don't refresh the page or reload the resources, you can happily interact with this app, even though the server's completely offline. If I was to refresh this now, I can see that it really is offline. So I'll turn those back on now. I'll go back to the main bit of the talk. Okay. Something else to bear in mind, I talked about auto being the best of both worlds. Essentially, if you actually looked in your dev console in your web browser, you would have seen that the resources for the latter 2 projects actually download more megabytes worth of stuff because there's more to download because there's some client-side execution going on with WebAssembly. Let's go back to my presentation. Okay, cool. So we'll move on to the next demo. So the next demo, number 4, is an interactive form that does some form validation. It really is really silly. If you type Adam into the name field, it'll tell you an error and say you can't be called Adam. There's some other silly things, like you have to tick the box to say you had breakfast this morning, because of course breakfast is the most important meal of the day. But there's also some interesting things to do with, there's a few other interesting things I'll quickly show you. Just going to bring this up again. Okay, so if we go on to example number 4, form validation. You can see that that little loading screen there was essentially saying that this is the WebAssembly files downloading and initializing. And so all of this is entirely local. There's no communication with the server at all. I am literally my server is just serving the files for you download, and this is all executed on your browser. So if I type in Adam here, it's actually going to give me a little validation error. There's only one true Adam, don't lie. I mean, I actually am Adam, but the validation's not that clever. There's some other interesting things. If, for example, if you tick this box at the bottom, you can do some cool binding of parameters. So essentially, if I tick this box, because it relates to the same C# variable, it's actually ticking the other box at the same time, which I think is a sort of cool feature of binding variables. So again. So this really is a very silly example, but it demonstrates some of the the client-side processing that you can do in WebAssembly, which is sometimes abbreviated as WASM. And then also there's that cool little down checkboxes thing where if you check one checkbox, it'll check the other and vice versa. And this is actually updating in real time with a C# variable, which is just a Boolean true or false in my, sorry, this is on the server, this would be locally, there'll be a C# variable. Cool, I'm gonna move on to the next slide. So demo number 5 is a bit more interesting. This is a real-time chat. I'm going to request that you don't say anything too naughty in the chat, otherwise I might have to turn it off. But it really is just sort of free text that you can type in. So if you type in your name when the login first pops up, I'm just going to bring up the thing again. So on the mouse. We go over to demo 5, real-time chats. Type in your name. Hopefully no one's taken Adam yet. Hey, there we are, with some words there. Interestingly, one of the features of this little demo is it's actually got a profanity filter. So don't push it too hard. Things probably will end up getting through. But if I was to type hello and I don't put the O on, it tells me off, because apparently hell's a naughty word. I hope no one minded me saying that. Yes, Scunthorpe is a good profanity that the particular plugin that I've used allows it to get away with. Yeah, but what's really cool here is obviously as soon as you type in a message, it's putting a kind of an update message out to all of your web page to say there's a new message here, please re-render it. Not a box like it. And another thing I would like to point out as well is if you refresh the page, it uses some local storage in the browser as well to restore your session and knows like who everyone is. Cool. Yeah, so essentially I've got kind of a C# web server service running that kind of keeps track of every page that's loaded, and basically there's a little push out to all of them to say that the page is ready to reload when a new message comes in. Yeah, and I'd also like to mention that there's a few sort of nice packages that have made this look nice. There's one called Blazor if you're interested in getting into Blazor, and that's a really nice set of UI components you can use. So I didn't design this chat at all. It came from nice little bubbles and stuff, which is really nice. There's also a package that helped me deal with the local storage and profanity detector. And if you want to do some LINQ stuff, if you've used C# LINQ is, I think does it stand for something like integrated query language, but the letters reversed or something? More LINQ, I know that gives you some extra interesting things that you can do with LINQ, which is convenient for manipulating lists. Cool. Okay, so the next example is a bit more interesting. What's a bit more interesting is maybe equally interesting. It's a little interactive game. There is no objective to this game, but if you go over to demo 6, and I think there's a few icons that have already been taken. I pick a wizard's hat, we can drag this around. And in real time, as you move your character around, it's updating everyone else. And this actually uses a different mechanism for updating everyone's browser. So instead of sort of registering an event handler with the server, instead it's actually using a separate SignalR hub. I don't know if you're familiar with SignalR hubs. I certainly wasn't a few days ago. But essentially, it's using a WebSocket connection to push out these updates. So when you click on your icon and move it somewhere, that's kind of just for you. And as soon as you let go, it's sending a push event out over these WebSockets to the client browsers, which will say essentially it's basically updating a style attribute in a little an image tag just to say this is the new position. And there's just a nice CSS transition that just makes it go smoothly to the new location. So yeah,
See, drag it slowly things on the screen.
Does it?
You don't even have to lift off. Yeah.
Oh, maybe I changed that. I thought I did it on the mouse up, but maybe it's yeah. I have to say it's handling better than I expected it would if it's updating all the time. Yeah, that's great. It's cool. Cool. Back to the presentation. So yeah, that's using the SignalR hubs, which is really cool. I thought it was using mouse up, but maybe it's actually using the drag JavaScript handler instead. Interestingly, it's got no persistence. So in actual fact, if you were to refresh the page, you wouldn't be able to set your icon anymore. Sorry, to set a new one, and your other one will stay forever in its place. That's just just for time. I didn't implement that part. Okay, cool. And I'm going to move on to the final demo now, which is, I guess, tangentially related to the work I do day to day at Savoy Systems. So this is a very, very, very basic seat selector. So if I go back to the main website and go on demo 7, essentially what it's going to do is it's going to allow you to go onto an event, and I think the counter was broken on the front. Oops. But essentially you can go through and you can select some different seats. And as soon as you've selected it, no one else can select that. But as soon as I have unselected it, I'm going to want someone to select F1 for me. Thank you. Yeah. And if we go on to a bigger one, There's 200 seats, which is on the right-hand side. You can do this. What's kind of cool here is you can also zoom and pan around as well. There's a little library that helps you with this, which sort of is basically a C# wrapper for this particular JavaScript library called panzoom, which allows you to use CSS transitions to manipulate an image. So if you've got a touchscreen device, you can pinch and zoom and tap on the seat and stuff, which is kind of cool. Cool. Back to the slides. Again, just because I didn't implement it, there's no persistence on this. If you refresh, you can't select your seats anymore. Sorry, they're gone forever into the ether. Okay, cool. So a little summary of those demos. I've given you sort of an insight into the different kind of hosting models and how they behave, for example, when the server goes offline. I've given you a little bit of an example on like the data binding. So there's the checkboxes, for example. That was a really simple example, but it can be really powerful if you update one UI part and it instantly updates another one just because you've bound to a C# variable. The code for that actually is really, really simple. I've given you an example also of an entirely WebAssembly app, that form validation app as well, is running entirely in your browser. With it being .NET, there's NuGet for managing your packages, and there's a there's a lot of packages out there if you want to make use of code people have already written and tested. And obviously, those final examples there were showing some real-time interactivity with other people with event handlers and Signal R. So, in summary, what I want you to take away from today is Blazor is pretty cool and WebAssembly is pretty cool. With that, thank you very much for your attention.